Hello, thank you for watching my video. Today we will be talking about chapter 10, DHCP for IPv6, part of semester 2, routing and switching, by me, Astrid Krasniqi. Stateless Address Auto Configuration, or SLAAC. Stateless Address Auto Configuration is a method in which a device can obtain an IPv6 global unicast address without the services of DHCP Server. So we can get a client machine can get an address, IPv6 address, without the DHCP server. They will make up the address themselves with the help from the MAC address and from the router. They will build an IPv6 address, unique IPv6 address. So here we have a DHCP client, v6 client, and a router. Now the DHCP v6 client will send a solicitation message. It's called router solicitation. I need a router advertisement from the router. Now this message is IPv6 all router multicast, similar to broadcast, but in IPv6 we don't have broadcast anymore. So IPv6 all router multicast address is like a broadcast for all routers. The router will hear that message and it will reply with a router advertisement message, or RA. Here is your prefix things, and other information. Now this is IPv6 all node multicast. It's like a broadcast message for the client. There's no broadcast in IPv6. It's only multicast as well, and other addresses, unicast, anycast, but no broadcast. Okay. The client will create a unicast address, global unicast address, and it will generate from the prefix that he's got from the router and his own MAC address. It will generate a unique global IPv6 address. Then it will do duplicate address detection, check that this address has not been taken by anybody or nobody is using it, which they shouldn't, because the MAC address, it should be unique in the world, but they will do a test anyway. Then we have a stateless against stateful DHCP servers. Stateful DHCP is centrally managed on a DHCP server, and the DHCP clients will use a stateful DHCP to obtain an IP addresses and other useful configuration information from DHCP server. So stateful means that there is a DHCP server running. Stateless means there is not DHCP running. It's not configured to store, and there's no DHCP server, and the clients will auto configure their own IP addresses based on the router advertisements. Stateless address auto configuration and DHCP v6. For example, the client will send that router solicitation message. Now router has got three choices, three types of messages they can send back. First one is SLAAC only, default. Only use the information in this router advertisement message. The second message could be the router can send SLAAC and DHCP v6. Use this information in the RA message and obtain additional information from DHCP server. And the stateful means don't use this message at all. Any information on this message, obtain all information from DHCP v6 server. Configuring a router as a stateless DHCP v6 server. We have a router and a client. First we have to enable IPv6 unicast routing on the router. Global configuration command. Then we create a pool, and in the pool we write the DNS servers, any information that we want to give to the client. Then we go to the interface, we add the IP address to that interface, and then we bind the pool with this interface. Okay, I will do a demonstration on this as well. So verifying stateless, show IPv6 DHCP pool, debug IPv6 DHCP details, and so on. We will do a demonstration now. I will use a packet tracer on this for this demonstration. What we're gonna do is one of the routers is gonna be our DHCP server. So I'll bring a router here, 1841, and say 2 PCs and another router. They connected with the switch. Okay, fast Ethernet there with a fast Ethernet 01 on the other router, fast Ethernet connection, fast Ethernet for the PCs, and fast Ethernet for the second PC. Okay, so this router here is gonna be the DHCP server. These are gonna be, these three here, they're gonna be our DHCP clients. All of them. The router, the PCs, the two PCs. So on the router, on our DHCP server, first of all, we need to enable the unicast routing. Okay. So I will use the notepad to do the configuration here so you get to see them. I'll open a new notepad and do startup configuration very quickly. So enable config t no IP domain lookup service password encryption, enable password Cisco, enable secret class, host name, this is going to be DHCP v6. Okay, and then line B2Y 0 to 4, password Cisco, login, line console 0, password Cisco, login, exec timeout 0 to 0, and login sync. I'll do a banner MOTD, okay, end, and then copy running config startup config. Okay, I'll copy all this to my router. This is the startup configuration. Check if there's any spelling. No, there's everything is fine. Okay, we have a DHCP server there. Now, for the DHCP v6 configuration, first I need to enable IPv6 unicast routing. So, config t IPv6 unicast routing. Then, I'll create a DHCP for version 6 a pool. So IPv6 DHCP pool, say DHCP v6 pool. Okay. Then I'll say prefix delegation pool DHCP v6 prefix. On this pool, I'm saying where is gonna be the prefix. What is it gonna be called? My prefix. Later we will configure the prefix. Then it will say DNS server 2001 DB8 and 5. That's my DNS server. Domain name example.com. Then I will do it on the interface, so interface FA00, no IP address, so no IPv4 address, IPv6 address, for this will be 2001 DB8 ::1 /64, and IPv6 DHCP server, and then I will link the pool with this interface. So this interface will be linked to the pool. IPv6 DHCP server, DHCP v6 pool, and no shutdown. Okay, the last thing we need to create that prefix. So IPv6 local pool This is going to be my prefix delegation. And it's going to be what I'm going to send to my client. So I'm going to send DB 2001 colon DB8 colon colon. This is my 64 prefix, and I'm going to send 64 bits to them as well, the first 64 bits. So here you can say how many bits you're going to send from this prefix. Okay, so I'm going to copy this configuration to my DHCP server. Check there's not any errors. No, that's fine. And then I'm going to configure my client, first client. So DHCP Client. This is going to be IPv6 unicast routing. Then go to the interface FA00 IPv6 address autoconfig IPv6 DHCP client prefix from provider. So we are getting the prefix from the provider, and IPv6, what we're gonna, after we add the prefix, what is gonna be our rest of our configuration. So the provider is gonna send us 64 bits, and what is gonna be the last? So say 100 or 10 /64. So the provider should send us this 64 bit, and for last 64 bits we're gonna use this. Okay, so I have copied and pasted the bit for the DHCP. I'm gonna just copy and paste it for the client. Go to the client, no here, and paste it. Config T. Okay, done. I just need to do no shutdown there. No shutdown. Right, all the sorry, all the configuration is done. So we just gonna need to go to PC0 and check the configuration the PC0 is getting. So go to desktop, then IP configuration, then DHCP. Then right away we got DHCP v6 request successful. This is the address 2001 DB8, and then we from MAC address we have built the rest of this address. Okay, and go to the second client, desktop, IP configuration, DHCP, done. We got the DNS server as well, 2001 DB8 ::5. This client machine is getting a DHCP address from the server. This client was getting a DHCP address, v6 address from the server as well, and the router now is getting the address from the DHCP v6 as well, the server. So we got the DHCP server, and there's some like commands to view that everything is working fine. We can say the first command, show IPv6 DHCP pool. Now this is our DHCP pool. This is a prefix. These are lifetimes for our prefix. This is our DNS servers. The domain name, what we have configured, and active clients we have 3. So if we bring another client in, we bring another PC and we connect it, that's going to go up to 4. So as soon as that goes green, we'll get a DHCP address, and we repeat the command again, and that should increase. Okay, this is red. You should know by now why. Spanning tree. Yep. Okay, so if you go to that PC and go to desktop, then IP configuration, DHCP, we get an address from DHCP v6. Repeat the same command on the router, show IPv6 DHCP pool, and now we can see that there's 4 clients there. Great. Now we see show IPv6 DHCP binding. Okay, with this command we can see what addresses we have leased to the client machine. Now if I go to the router, to the client router, and repeat the command show IPv6 interface brief, show IPv6 interface brief. Now you can see that this is the local address. Let's come up with this address, FE80, and this is the global unicast version 6 address. Okay, now I'll show you how this client machine will build a unique DHCP address, DHCP version 6 address. Okay, I have a client here and a router here. Now the router is going to do the router advertisement array. In that router advertisement, there is the prefix, the network part. So for example, 2001 db8 : 64-bit. Now IPv6 is made out of 128 bits, so we're going to need 64 bits, the network ID, and the client is going to need a 64 bits here in the end for host ID. So we have 64 on this side and then 64 on this side. This 64 bit for the client ID, it will build from his MAC address. So MAC address is 48 bits. For example, AA, BB, CC, 112233. That's the MAC address. So from this MAC address, the PC is going to build his own client host address. So it's going to add FFFE in the middle. So AA, BB, the MAC address becomes CC, FFFE, and then 11:22:33. Now the client machine has already got a 64-bit host ID. What it needs to create this unique IPv6 ID is the first 64-bit. So that's why it's going to do the router solicitation. So it's going to ask the router, says, okay, can you please send me the first 64-bit? When router hears that message, it will send the first 64-bit on this side. Now the client has got a unique IPv6 address, globally unique, and it can go to the internet. Thank you for watching my video. This has been Astrid Krasniqi.